Hello and welcome back to another video. In this video we are going to discuss the next three questions from paper 970931 of October November 2019. So here is the fifth question. The curve with equation y is equal to e raised to the power minus 2x ln x minus 1 has a stationary point when x is equal to p. So where it is a stationary point at that time x is equal to p. So we need to show p satisfies the equation x is equal to 1 plus it is e exponent, that is e to the power 1 over 2 times x minus 1, where exponent of x denotes e power x. So we need to find the dy over dx, and when it is a stationary point, means when you will put it as 0, then at that point x will be p, and we'll prove that x is equal to this. So it means p satisfies this equation. So first of all, what is dy over dx in this case? We can see there this is the product of two functions, so we are going to use the product rule in order to find the differentiation of it. So first function as it is, that is e raised to the power minus 2x, into differentiation of second function, it is log function, so it is going to be 1 upon x minus 1, into differentiation of x minus 1 will also be there because of the chain rule, but differentiation is 1, so no need to write, plus first function second function as it is, and the differentiation of second function first function, and the differentiation of first function is e raised to the power minus 2x, that is e raised to the power minus 2x as it is, into, by the chain rule we are going to differentiate the power, and that is going to be minus 2. So I will rewrite it, and this is going to be e raised to the power minus 2x over x minus 1, and here is going to be minus 2 ln x minus 1, and here it is e raised to the power minus 2x. So for stationary point, dy over dx is equal to 0. It means this will be 0, so we will write, I'll take this thing to the other side, and I'll get 2 times e raised to the power minus 2x into ln x minus 1 is equal to e raised to the power minus 2x over x minus 1. Now we know it's exponential function, so it will never be 0, so we can cancel these two, and we will be left with only ln x minus 1 is equal to 1 upon 2 times x minus 1. Now we know if it is ln is equal to this, so we can directly write that x minus 1 will be e raised to the power the whole thing, and I'm going to write in the same form, exponent of 1 over 2 times x minus 1, or the final answer, that is x is equal to 1 plus exponent of 1 over 2 times x minus 1. So now it is at a stationary point, so at a stationary point x is equal to p, so it is going to be satisfying the p as well. So I hope it is clear. Let's do the next part of this question. Second part, verify by calculation that p lies between 2.2. So we have an equation from first part for which the p satisfies, so we'll write it, and that is ln x minus 1 is equal to 1 upon 2 times x minus 1. This was a equation and p satisfies this because we got this equation by making dy over dx is equal to 0, that is at stationary point, and at stationary point x is equal to p, so it satisfies it. Now we'll make a function out of it so that we can find the value at these 2 points. So I'll take f of x by taking let's say this thing to the other side, and we will get ln of x minus 1 minus 1 upon 2 times x minus 1. So let's find f of 2.2 by calculator, and let's say minus 0.235 4, 3 and so on. And similarly we can find for f of 2.6, and this is 0.1575 and all. So we can see from here that f of function value at 2.2 is below the x-axis, and function point as the value at 2.6 is more above the x-axis. So it means the function, this equation, or we can say the root of this equation, which is of course p, is lying between 2.2 and 2.6. So from here we can say that p lies between 2.2 and 2.6, as f of 2.2 is less than 0 and f of 2.6 is greater than 0. So I hope it is clear. Let's do the next calculation, next question. Here's the third part. Use an iterative formula based on the equation in part 1 to determine p correct to 2 decimal places. Give your result of each iteration to 4 decimal places. So from the first part we know that p satisfies this equation, x is equal to 1 plus e raised to the power 1 over 2 times x minus 1. So we can take this as pn plus 1 is equal to 1 plus, I'll write exponent of 1 over 2 times x minus 1. Now we have from the second part we have calculated that p lies between 2.2 and 2.6. So we can take as an initial value as I'll take this as pn p naught as 2. Let's say 4, a mid value between these two, and then p1 from this iterative formula we will get 1 plus exponent of 1 over 2.2 into 2.4 minus 1, that is 1.4, and this is from the calculator, it is 2.4292 and so on. So 2.4292, because we need to write the answer till 4 decimal places. And from here we can get p2 also just by replacing this value as p1 here, and we will get it by calculator directly, so we don't have to write it again and again. So it is going to be p1 minus 1. So we can get it from the calculator just by replacing that particular value with the answer key. So it is going to be 2.4141883, so it is 8, and hence it is p3 by just pressing equal to button we can get the next value 2.42247, so it is 5, and then similarly we can get what is the value of p4 just by pressing equal to button, and we will get it as 2.4211, and then p5 is also 2.4216. so we can say that till 2 decimal places the correct answer is 4 2. So the answer of this is p is going to be 2.42. this is the answer of the this is the value, correct value of p to 2 decimal places. So I hope it is clear. Let's do the next question. Here's the question number 6. By differentiating cos x over sin x, show that if y is equal to cot x, then dy over dx is equal to this. So we need to find the differentiation of y is equal to cot x with the help of making cot x as cos x over sin x. So y is equal to cos x over sin x. I have written in place of cot x it as cos x over sin x, because we know that cot x is equal to cos over sin. So from here we are going to use the quotient rule for this differentiation. So dy over dx is equal to, and the wonderful way to remember, start with the denominator, square it, and then write the same thing again, then do the differentiation of cos x, that is minus sin x, minus the numerator as it is, and then differentiation of denominator, that is again cos x. So altogether we got it as minus sin square x minus cos square x over sin square x. Now we know the identity. Before that I'll take minus common, and we'll get sin square x plus cos square x over sin square x. So we know the identity, sin square x plus cos square x is 1, so it is minus 1 over sin square x, and that is minus cosec. The next part of this question. Here's the second part. Show that integration from pi by 4 to pi by 2 x cosec square x dx is 1/4 of pi plus ln 4. So from the first part we have seen that ln if y is equal to cot x, then its differentiation is, that is dy over dx, is minus cosec square x. So it means the integration of minus cosec square x would be cot x, or we can say from here the integration of, because we know that they are the reverse of each other, so cosec square dx will be minus cot x. So this is what we are going to use here. So here we can see it is, there are two function x and cosec square x. So we are going to do the integration by part. First function is x and second function is this. So let's use this property. So it is like integration will be, I'll take it as I. Integration is first function as it is, that is x, and cosec square x integration of second function, and it is going to be minus cot x. So minus times cot x minus integration of differentiation of first function, that is 1 of course, because differentiation of x is 1, and integration of cosec square x, that is going to be minus cot x dx. So we can rewrite it again. It is going to be minus x cot x, and it is going to be minus plus integration of cot x dx. The limits will be everywhere same, that is minus pi by 4 to pi by 2. And then now we are going to separately solve what is the integration of cot x dx. Now integration of cot x dx from pi by 4 to pi by 2, it is going to be again written as cos x dx over sin x, and if we substitute sin x as t, so differentiation of both the side, it would be cos x dx over dt is 1, so I'll write cos x dx is equal to dt, and hence we'll substitute it here. We'll get it as dt over t, and which is of course ln modulus t, that is I'll write only t because it is going to be positive in pi by 4 to pi by 2. So now let's change the limits as well. When t is equal to pi by 4, x is equal to pi by 4, then sin x will be 1 by root 2, so t is going to be 1 by root 2. And when x is equal to pi by 2, when x is equal to pi by 2, that is 90, then t become 1. So it is going to be till from 1 by root 2 to 1, and we'll put the limits here, and finally we'll write the answer directly from there. 1 by root 2 to 1, and that is going to be ln 1 minus ln 1 over root 2. ln 1 over root 2, and ln 1 is 0, so and this is minus, so I can take it as ln, and this minus 1 will go in, then it will make it reciprocal, so it is going to be 1 over root 2 inverse, so I'll take it as root 2 only, and root 2 also we can write it as ln, because we require 4 here, so I'm writing it as 4 and whole to the power 1 by 4. 4 whole to the power 1 by 4, because root 2 is 2 raised to the power 1 by 2, and then this 2 I'll write as 4 raised to the power 1 by 2, so 1 by 2 into 1 by 2 is 1 by 4. So from here, if we'll replace it, we will get it as I is equal to upper limit, so it is going to be minus pi by 2 into cot of pi by 2, it is 0, minus the lower limit, and minus minus it is plus, lower limit is pi by 4 and cot pi by 4 is 1, and plus the integration of this within this limit, it is going to be 1 by 4, because it is ln a to the power b is going to be b ln a, so it is ln 4. So altogether we got the answer. It is going to be pi over I'll write 1 by 4 because it's given in that way, 1 by 4 common, pi plus ln 4. So that's it. I think it is, I hope it is fine. Let's do the next question. Here's the question number 7. Two lines L and M have equations as r is equal to a I cap plus 2j cap plus 3k cap plus lambda times this, and r is equal to 2ij 2k and mu times this respectively, where a is a constant. It is given that the line intersects. If the lines are intersecting, it means if we take any random, any general point on the line, and if we equate them, there would be one point, there would be the lambda and mu, fixed lambda and mu, for which this will be satisfied. So we'll start with the writing the general point on line L. It is going to be I components together, j component together, and k component together. We can take it as a plus lambda I cap plus 2 minus 2 lambda j cap and 3 plus 3 lambda and k cap. This is any general point on L. And same thing, general point on M, it is going to be 2 plus 2 mu, 2 plus 2 mu, 2 mu I cap plus 1 minus mu j cap and 2 plus mu k cap. So if these lines are intersecting, it means if we can equate at for some particular lambda and mu, a plus lambda should be equal to 2 plus 2 mu for some particular lambda and mu, and second one is 2 minus 2 lambda is equal to 1 minus mu, and third one is 3 plus 3 lambda is equal to 2 plus mu. Now we will take this equation as 1, 2 and lambda and mu from the last two equations, and we'll put here so that we can get the value of a. So from 2 and 3 we can see if we add 2 plus both the equation, we'll get rid of this mu, and that is going to be 2 plus 3 5 plus lambda minus 2 plus 3, that is going to be lambda, is equal to 1 plus 2 3. So from here we got lambda is equal to minus 2. So once we got lambda is equal to minus 2, I'll put it here, and from 2 we'll get 2 minus 2 into minus 2 is plus 4 is equal to 1 minus mu, and that's why mu will be 6 and then minus 1, so 5. So it would come here, it is going to be minus 5. And it would be a is equal to, it is minus 8, minus 8 plus 2 is minus 6. So the value of a would be 6, minus 6. I hope it is clear. Let's do the next. So here's the second part. When a has this value, that is when a is equal to minus 6, find the equation of the plane containing L and M. Equation of plane, now it is not in the syllabus, though we can do it by making those line equation, equate the line of equation, and then we'll find the values of lambda and mu. We'll eliminate the value of lambda and mu to get the equation in x and y and z. So that's not in the syllabus, so I'll not do it. So that's it for this video. Thank you so much. We'll see in the next video.